I'm Jessy Grizzle, Director of the Robotics Program, and I'm here to tell you about Robotics 101. We're building in equity and opportunity from the ground up. So I'll first give you a high-level summary of the course. The fundamental principle we have for it is that talent is uniformly distributed, but opportunity is not. So we really wanted to look at what are the requirements you need so that you can start being involved in engineering from day one. And we decided that a curriculum that confronts students with a long sequence of calculus courses with a lot of material that is covered just in case you're going to need it in major X is not really the right way to go. We really haven't changed since Sputnik. So we decided to take a brand new look. We are going to start the curriculum with linear algebra combined with computation. Okay, so let me get into a few more details. You can scan these QR codes and go online and find postings of all of the lectures of Rob 101 on YouTube, plus the homeworks. So we really wanted to get students going on how do engineers think about mathematics. So this is very different than getting closed form solutions to every problem. By getting linear algebra up front, I'm going to show you some amazing applications that we ran as projects. It's really letting students experience engineering right away, not having to wait until they're juniors or seniors in the program. Once again, equity. If you were not encouraged to take math, your high school did not have available AP courses because of your zip code, we're able to take you into Rob 101. What we said was if you know the quadratic equation, that's the fundamental background. So by doing triangular matrices and motivating forward and back substitution, that then this came from the students, well, okay, these look like really special cases. Can we really solve general problems with these techniques? And the answer is yes. If you use the LU, the lower upper factorization, you can. Now, I'm going to show you some projects. The way you build material for a diverse group of students is you construct a diverse team. So our first project was we gave the students 90 megabytes of LiDAR data collected by the Cassie robot on the Grove, and we had them register the scans coming from the LiDAR sensor to build a map. The second project, we took advantage of the inherent interest in machine learning. It's really been a hot topic, and we did a linear regression-based version. So we're still using radial basis functions and things that are common in machine learning, but the mathematics for calculating the coefficients we reduced to a classic linear regression problem. And then we gave them some climate data and had them build a two-dimensional map. And then the final project, they were doing model predictive control, MPC, a very simplified version. Because we had done the bisection method and Newton's method and then the optimizations, the students were used to these iterative processes. So to understand the solution of a dynamic model was kind of a natural thing for them. Now, a side effect of them working on these types of projects was something that we did not anticipate at all. Students going, oh, I really like control. I want to get into ME461 or EX460. This is the path I have to follow, and they're sharing it with their friends. This other student is saying, oh, computer vision, that was this most awesome thing. This is what I need to go to get through there. Somebody else, it was machine learning. One of the students reported to me that when she was enrolling at Michigan and looking at the college curriculum course guide and just saying all these terms just seemed like incomprehensible and why would I ever take those, that when she was finished with Rob 101, she was reading the college course guide going, I can't wait to take this course. I now know what this means. This is so exciting. Well, how I like to always end any talk I give about the Robotics Institute is with this slide. I mean, you see our wonderful students. What I really like is it talks about what we do, create smart machines, how we do it, we work together, and why we do it, we serve society. And by developing this undergraduate program, we're going to be able to serve society even better.